Hi, welcome to this short video where I want to highlight some of the amazing work that the folks at TMForum have been doing. You can visit the OpenAPI directory and you will see that they have over 100 APIs that have been captured. And for each of these APIs, they have provided a whole set of assets that are very useful for anyone implementing these in the telco domain. So let's look at Trouble Ticket, which is one of the APIs that is provided. As you can see here on the top, there are several different versions of this API, very nicely maintained. There's also an asynchronous version of this, which we will talk about later. And then if you scroll down, you would see that there is an OpenAPI specification for this. There is a reference implementation or a sample implementation for this. And there is a CTK, which is a conformance toolkit, which someone who wants to get certified that they have implemented this API correctly can use the CTK to, basically run the CTK and validate if their implementation is conformant with the specification, with the OpenAPI specification. So as we were looking at this and we thought that this is amazing work, but there is some room for improvement in terms of the architecture of the CTK and RI and also with the speed with which we will be able to build these out. So that's what I'm going to kind of quickly try and cover in this demo. Okay, let's jump in and look at the architecture and see what are the challenges that we found and how we have tried to improve them. So the current architecture, basically, as we just looked at, has a OpenAPI specification on the TMForum website. Then from the same place, you can also download the CTK itself. The CTK internally uses Cypress for making requests and then validating the response against a implementation, against a reference implementation. The CTK itself contains a copy of the OpenAPI specification. And that is the first problem that we believe that this specification can go out of sync with the one that is on the website. And so we should ideally have just a single source of truth and not a copy of this. The changeme.json contains the payloads that are required to run against this specific reference implementation. And so what Cypress does is it basically picks up the payload, sends the request to the reference implementation. Now, the second challenge that we see is before sending these requests, ideally you would want to validate whether these requests are as per the specification or not, right? That's not happening as of today. Once you get the response, of course, that is validated against the specification, but there is also quite a bit of API tests that are written in Cypress that basically validates the response, the error code, not necessarily the error code, but the paths and the method and so forth. And that can again go out of sync with the specification. So we believe that this should be avoided. Now, if you pop open the CTK, you would actually see the Cypress code that is available. And that's quite a bit of code that someone had to write to implement this. And that's probably one of the reasons why building these CTKs can be a fairly involved job. Also, providing the source code of the CTK test itself to someone who's running the CTK may not be a great idea, right? Because someone can now muck around with these tests and even though they're not passing and make it look like they're passing and so forth, right? Because they have access to the code. So generally, we would recommend to seal this away and not make it accessible to anyone running the consumer of the CTK. Of course, once the response is validated, then a report is generated. And what you will see is that the report only covers very few aspects in general, right? So again, here you would see that we are not doing request validation. We are certainly doing response validation, but notifications, if you see the specification, they do have a lot of notification and the notifications are actually not being asserted, nor are the error code, response code, the optionality and so forth are getting validated. So let's look at how we're proposing to improve this architecture, right? So instead of having the OpenAPI specification from a website, we propose that we put it in a Git repo and then we pull it from the Git repo because it's more easier for programs to consume it that way. We have a generic CTK now. We don't have a CTK which is specific to each API, but we have a generic CTK which is also Dockerized. And this CTK internally is powered by Specmatic, where we're using contract tests that Specmatic is known for to basically do the conformance testing. this Specmatic itself will pull at runtime the OpenAPI specification from the Git repo, which is the single source of truth, and it's not duplicating any of this stuff. All payloads that are required for the reference implementation are also externalized, which gets mounted into the Docker image. And when we mount these payloads, we actually also do the validation against the specification. And then the change me just points to where is your reference implementation running, so that we can then make a request. So Specmatic will construct a request from the payload and send it to the reference implementation. Now, what we've also done is basically built a generic reference implementation. We don't need a reference implementation per API. So we've built a generic reference implementation and we've Dockerized that. Again, this is powered by Specmatic Service Virtualization, where we are able to essentially take a OpenAPI specification at runtime and basically start serving responses for as per that specification, right? So that's the service virtualization piece, which basically uses the specification to run it. So whenever a request comes, then basically the Specmatic Service Virtualization stub would be able to respond back with the response code, and it's also capable of sending notifications and so forth. And this is now all of this stuff can be validated and a similar report can be generated as before. So in summary, if you look at it with these changes, we are able to not only validate the requests, response, the notification, error responses, the optionality, nullability, but we're also significantly reducing the time it would take to build the CTK and the RI because we have made them generic. And the only thing that changes for these two things is the specification and the data, the payloads, which is basically loaded at runtime. So enough of slide deck. Let's jump in and actually look at what the source code for this looks like, right? And what would be the experience for someone. So let's assume you basically download the CTK and RI. You would essentially have a simple README instruction file, which basically lets you to start up the RI and CTK. Let's quickly pop the hood and look at what is inside the reference implementation and the RI. So you would quickly notice that there is a Docker Compose file. So everything is Dockerized like I mentioned earlier. So there is a Docker Compose file. This is basically pulling Specmatic's latest image, and it's essentially running the stub command and providing the examples. The examples are basically what are loaded from here. These are the request response payloads. And that's pretty much it. That's all is required for the reference implementation. And the only other thing you might be interested is to look at this configuration file from Specmatic, which basically is saying, hey, here's, this is the repo in which my contracts exist, my specifications exist, and this is the specific one that I want to service virtualize, right? And so with that, if I go ahead and essentially run the reference implementation, you'll see that it's basically pulling the latest version of Specmatic from Docker and spinning up, Specmatic. And here you will see that it's basically tried to look for where is the specification. It says, okay, the specification does not exist. It's basically pulling this, it's cloning this repo and pulling the specification at runtime, right? This ensures that there is a single source of truth and it's always up to date, right? And so it's loaded the specification. It's found out that the 16 parts, 23 operations, and it's basically gone ahead and loaded all the examples that we've provided. We've intentionally left some errors in the specification in the example so that you can see that there is actually a validation also happening for this. If there are things that are invalid, it will not load them. And with that, it basically has started the reference implementation on port 9000. So with that, let's look at now the CTK itself. So what is inside the CTK? The CTK, you will see, is very similar. It'll have a Docker Compose file. Again, it's basically using latest version of Specmatic. And essentially, it's loading the examples. And the command that we are running here is the test command, which is the contract test command in Specmatic. Let's look at the Specmatic.yaml. Again, you will notice that we are pulling the latest version of the TMF 621 OpenAPI specification from this Git repo, and we are starting the this thing. And here are the examples which we will be using So as a user, you may want to update the examples to match your specific implementation. But if you're running it against the reference implementation, they're already all up to date and working. So let's quickly go here and start the CTK itself. So just click that and it'll run the ctk.sh. Again, you will see that it's cloning the repo, it's pulling the latest version, loading all the files, and it finished. I mean, it's pretty quick. It just ran in a jiffy. And you'd see that 5 tests have run and all 5 tests are successful. Let's quickly look at what actually happened here, right? So I'm just scrolling all the way to the top. So you'd see that it first looked for this OS file, the OpenAPI specification file. It did not find it, so it cloned it, pulled the latest version, and then it loaded it. Again, you will see the same information, 16 API paths and 23 operations. After that, it's loaded the examples. All the examples are valid. And so it's loaded the example and it started sending the request now. So you'd see here it did a post on trouble ticket. This is to create the trouble ticket, and it would have got a response back, which is a 201 created successfully, and it does a validation whether the response is as per the specification or not, and so forth. And then it will obviously go and get the trouble ticket that was just created. So we do make sure that whatever trouble ticket was returned is what actually then gets queried and so forth. So this ensures that the tests are always going to work in a certain workflow, and all of them are succeeding. So if you can see, all of these have succeeded. Finally, it does print a coverage report which shows you what all was covered as part of this. And so you'd see that we have covered all of these things. And finally, these are the reports. So let's quickly now open the report and see what the report looks like. So this is the new updated CTK report. So again, we've tried to make it very visual, so you can see what all paths existed, /trouble ticket, /trouble ticket ID, what methods were exercised, what response codes were exercised, and how many such tests ran. So in this case, 2 tests had run. Let's click on this to look at the details, right? So here you would be able to see what specific request was sent, what was the response it got back. In case some test fails, it's quite handy to debug things this way, right? So that's kind of the details that you would see in the report. So I think this is pretty much what I had in mind for the demo. I hope this helps you understand how we are improving the whole CTK and RI experience. And this will truly speed up the development of the CTK and RI and make them accessible more quickly to the members so that they can leverage all the amazing work that the folks at TMForum have done.